Ever stop and think about what's actually going on behind the scenes, behind your screen? We're about to pull back the curtain on the invisible language that makes our entire online world tick. And believe it or not, we can boil it down to just 10 key acronyms. Let's trace the journey. So think about it for a second. You click a link, and poof, a web page just appears. It feels instant, right? But that one single click kicks off this incredibly complex, high-speed journey. So how on earth does your request find its way across the globe and back, literally in milliseconds? Well, turns out it's not just random chaos. There's actually a map for this journey, a kind of standardized blueprint that lays out the rules for how data gets from your screen to a server and all the way back again. And that map is called the OSI model. The easiest way to picture it is like a 7-story building where every single floor has a very specific job. You've got the physical cables down in the basement and the app you're actually touching and using on the top floor. The OSI model just gives us a clear way to talk about every single step in that process. It's really the fundamental blueprint for how networks talk to each other. But here's a key distinction. While the OSI model is the perfect official map, it's not actually the car that's doing the driving. In the real world, the internet runs on a more practical, streamlined set of rules called TCP/IP. Think of it as the super efficient vehicle we're going to be riding in for the rest of this explainer. All right, so our digital journey is about to kick off. But before your computer can send even a single bit of data out into the world, it needs to get 2 crucial things sorted out first. To get online, your device has to do 2 things, and thankfully, it does them totally automatically. First, it needs to get its own address for the network it's on, and second, it needs to find the address of where it's trying to go. This all happens in the background thanks to 2 really clever protocols. The first one is DHCP. The best way to think about this is like the front desk at a hotel. The second you connect to a Wi-Fi network, DHCP is the concierge that says, "Welcome, let me find you an empty room." It then hands you a key, and that key is your temporary IP address. It's totally dynamic, completely automatic, and it's what makes just connecting to a network so seamless. So once you have your own address, you need to figure out the address of where you're going. That is where DNS comes in. See, we humans remember names, like example.com, but computers, they only understand numbers. DNS is basically the entire internet's giant shared phone book. It instantly looks up the name you typed and translates it into the numerical IP address the computer actually needs to send your request to. Okay, so quick recap. Our device has its own IP address, and it knows the IP address of its destination. The first part of the journey can now begin, and it starts on the local streets, right there inside your own home or office network. You can think of it as your digital neighborhood. And this digital neighborhood, that's your LAN. Your local area network. It's just all the devices in your immediate area, all connected together with Ethernet cables or through Wi-Fi. These are the small, local side streets your data has to travel on before it can get to the big main highway. But here's where it gets really interesting. To navigate these local streets, your device needs a totally different kind of address. That IP address we got is temporary, it's logical, but for local delivery, from your laptop to your router, every device also has a physical address that's burned right into its hardware. And this difference is key to how the whole internet works. And that physical address is called a MAC address. Think of it like your device's unique fingerprint or a serial number that's stamped onto the hardware when it's made. It never, ever changes. On our blueprint, this all happens at layer 2, the data link layer, and it's what makes sure your data gets from, say, your computer to your Wi-Fi router correctly. So what happens when these local networks get really crowded and busy? Well, that's where VLANs come to the rescue. A virtual LAN basically lets a network administrator take one big physical network and digitally slice it up into several separate, smaller ones. It's like creating digital carpool lanes or private subdivisions. This keeps traffic separate, which is great for security and for performance, even when everyone is using the exact same physical wires. All right, our little data packet has successfully navigated the local neighborhood. It's made it to the on-ramp. Now it's time to merge onto the global data highway and travel across the world. This global highway system is what we call a WAN, or a wide area network. It's the absolutely massive web of undersea fiber optic cables, satellites, and high-speed circuits that connects all of our individual little lands together. In fact, the internet itself, it's really just the biggest WAN on the entire planet. So at the end of the day, the difference really just comes down to scale. Your LAN is your local neighborhood, using tech you know like Wi-Fi. The WAN is the global system of highways that connects whole cities and countries. Our data has to start on the LAN to even get to the WAN to complete its journey. And how does our packet navigate this massive global highway? Well, remember that IP address we got from DHCP way back at the beginning? This is its moment to shine. This is our layer 3, or network layer address. It works just like a global mailing address, and routers all across the world use it to forward your packet from one network to the next, getting it closer and closer to its final destination. So let's just nail this down because it's super important. Your MAC address is physical, like a serial number on a car engine. It's for local travel only. The IP address is logical, like the mailing address you write on a letter. It's for global travel. You need both to get where you're going, and having these two separate address types is what allows you to take your laptop from a coffee shop to your home to the office and connect seamlessly every single time. But the internet isn't a total free-for-all. As your data zips around the world, it has to pass through security checkpoints. And these are handled by ACLs, or access control lists. Just think of an ACL as a bouncer or a traffic cop standing at the border of a network. It looks at every packet, checks its source and destination against a list of rules, and decides you can pass or nope, you're denied. It's one of the most fundamental tools for network security. Okay, we have covered a ton of ground and a whole lot of acronyms. So now, let's put all the pieces of this puzzle together and watch our little data packet make its complete journey from start to finish. So here's the whole trip in a nutshell. Step 1. Startup. Your device gets an IP address from DHCP and finds the website's address with DNS. Step 2. Local travel. It gets sent across your local LAN using a MAC address. Step 3. Going global. It hits the worldwide WAN, using that IP address as its mailing label. And step 4. Security check. It passes through all of the ACLs on routers and firewalls until it finally arrives. And all of that, every single step, happens in less time than it takes to blink. It's just incredible. It really is an incredible, invisible system, a silent language of addresses, lookups, and rules that connects billions of us every single day. The language might be hidden from view, but its power is absolutely undeniable. And it just makes you wonder, what's it going to take to keep this intricate, beautiful dance running smoothly when the next billion people join the global conversation?